example, we are going to classify each number into its set. So the thing to remember is that each number may belong to more than one set. All three of these numbers are real numbers, so they belong to the real numbers set. Inside of the real numbers, we have natural numbers, whole numbers, integer, rationals, and irrationals. Let's start with the number negative 23. The number negative 23 is negative, so when I look at this list of examples, this one right here shows negative and whole numbers, and it says the set of integers includes the negatives of the natural numbers and the whole numbers. So that means that the number negative 23 belongs to integers. And the symbol for integers is this Z that is like bolded, kind of. Now, remember that numbers may be classified into more than one, so let's keep going. Let's look down the list. Rational numbers. The set of rational numbers is the set of all numbers that can be expressed as a quotient of two integers. So two numbers being divided can equal 23 for sure. And we could also write negative 23 the same way negative 17 is written. Negative 17 can be written as negative 17 over 1, which makes it rational. So also, the number negative 23 is rational. The symbol for rational is this like bolded Q. Since this is a rational number, it cannot be irrational, because irrational numbers are numbers that are not rational. Now let's look at the second number we have here, square root of 50. First thing I want to do is check if the square root of 50 is a perfect square. I'm going to simplify this. The number 50 can be written as 2 times 25. 2 times 25 is 50. If I take the square root of 25, I get 5. 2 is not a perfect square, so it stays inside of the radical. So the number square root 50 is the number 5 square root 2. We know this is not a natural number. This is not one of our counting numbers. It's not a whole number because this square root 2 is going to be some kind of decimal. If it's not a whole number, it's also not an integer. Rational numbers have, if it's a decimal, it's either stops, it is a terminating decimal, or it is a decimal with a repeated pattern. The square root 2 does not have a repeating pattern, and we can see right here that the square root of 2 is irrational. So this number, 5 square root 2, belongs to the irrational numbers. The symbol for the irrational, we're going to use this bolded I. Last one, negative 4/9. Negative 4/9 is not a counting number or a natural number. It's not a whole number because whole numbers are the counting numbers that just include 0. It's not an integer because, again, it's not a whole number. It is rational because it is a fraction like 2/5 or negative 2/5. So this is negative 4/9 and it is a rational number. And the symbol for rational numbers is this bolded Q.